So yeah, we're going to talk about .NET Core 3.1. Actually, it was .NET Core 3 until about a month ago with the Raspberry Pi. So, I mean, the circuit we'll be talking about is sitting at the front here. It's really complicated, so just watch out. It's just proof that it works more than anything. So this is me. I'm a freelance developer. I'm based up in the Midlands in Loughborough. Pretty much born and bred around there, so university there and everything. So. I've, like Dan's just said, just recently been awarded an Azure MVP as well, which makes me feel happy, mostly for doing stuff like this. But I also run 3 meetup groups in Nottingham, .NET Knots IoT, and Knots Dev Workshop as well. So that keeps me busy, as well as the 2 girls and a wife at home. So yeah, lots and lots of stuff happening. So as far as what we're going to talk about, obviously if we're going to talk about .NET Core, you've got to learn where cores come from a little bit. So we'll talk about .NET Framework and then .NET Standard. And then I'm not going to show you how to install it on the Raspberry Pi because that's boring. I've got a blog post for that I'll give you a link to, but I'll take you through the basic steps of how that works. And then obviously Hello World, and then flashing an LED, which is Hello World again. And then maybe some IoT Hubs, Azure stuff as well. So, and then we'll finish up with a bit of Blazor. But before I carry on, who's dabbled with IoT? You've come to an IoT talk. I'm hoping that at least some of you have. Not as many as I would have thought, actually. Interesting. Have you come because you want to dabble with IoT? Is that what it is? Right, good. Well, you come to the right talk then. So, starting with .NET Framework, who's a .NET programmer here? You've come to a .NET user group, so I'm hoping most of you. You know, you can pretty much program anything with the regular .NET Framework, everything from desktop all the way up to AI stuff, which is great. It's really good. And you can write in C#, F#, or, you know, VB if you want to. Actually, I do. It's embarrassing. Anyway, it's been around for a good long time. It was announced right at the start of the noughties and then released 2002. So it's a well-bedded in framework by now. Loads of stuff happened between 2002 and 2007, but at 2007 we got WPF, which this chap's going to be talking about at some point. I like WPF, like a bit of XAML. It's good stuff. Excellent stuff. And then we got Link and Async in 2012, and then Visual Studio 2015 in, surprise, 2015. And then we got the first version of .NET Core. Who used the first version of .NET Core? And you're still alive. Impressive. You didn't hang yourself. That was troubling for a lot of people, I guess, because it wasn't as released as I think a lot of people thought it was going to be. Then 2017, and then it wasn't until 2018 that we got a real version of .NET Core, if you will, at .NET Core 2. And then today we're all the way up at 3.1 and Visual Studio 2019. And if you want to use some of the newer bits, then you need to be using the preview version of that. So .NET Standard came about because we had all these common infrastructure bits and bobs, and then we had a base class library, a core library, and a mono class library that the .NET Framework, .NET Core, and Xamarin all sat on top of. And if you wanted to make something that was compatible with .NET Framework and .NET Core and .NET Xamarin, then you had a hell of a time trying to figure out which APIs you could use across all of those, and then which versions of each of those were going to work on which platform. That was a problem quite a while back as well, if anybody remembers Silverlight. Yeah, beautiful. Obviously, there was .NET Framework, and there was Mono, and there was Silverlight, and there was Forms, and you had all of those different platforms, and you had to try and figure out yourself how to go about making code that was portable. There was things called PCLs. Anybody made PCLs back in the day? Yeah, excellent. Well, this is what's replacing PCLs, is .NET Standard. And can you remember what the numbering system for PCLs was? No, because it didn't make any sense whatsoever. So they came up with the idea of, let's just make all of this lot a standard. So it's not a framework, it's a contract, it's a specification for what you can use if you're going to build a library on top of that, an implementation. .NET Framework, .NET Core and Xamarin are all implementations, Mono as well, which is, you know, sort of 2-in-1 in Xamarin to a degree. They all implement a certain version of the .NET Standard library. So now you can build all of these and you can move your code around so long as you use a certain version of the framework that targets a certain version of the .NET standard. There is a table. This is a reproduction of that table. The table doesn't actually make it that much easier to understand, but it's a table, and you've got to have a table. You can find out a bit more information with that link there, but you can sort of see we're at .NET Standard 2.1 with .NET Core 3 and above 3.1 that we're on today. So what they say is that if you're developing a client application, try and target the highest version number you possibly can, and then everything else below that is going to be supported. If you're making a client library that you intend to be used across multiple platforms, try and target the lowest common denominator, and then everything else will be supported above it. So it's just kind of a rule of thumb. But you can see, I mean, .NET Framework 4.8 and Mono 6.4, and you can see these various different bits, but .NET Core 3.1 and 4.8. So you should be able to take code, obviously not WPF if you're going to move it to Linux, but to a great degree, you can move code between those platforms quite easily. So .NET Core, that's what Wikipedia says it is. It's an open source platform that runs anywhere, really. And it really does. It's cool. In fact, I saw today somebody managed to compile it to work on Windows 3.11. Incredible. Someone's got a whole blog post on how to do it. Why? I'm not quite sure why. In fact, it came from an implementation targeting DOS, which just sounds crazy to me. But this is what happens when you make something open source, is people, it'll be on fax machines before you know it, alongside Doom. So yeah, cross-platform, high performance, it really is as well. This version 3.1 is long-term support, so it's going to be supported for about 3 years. So you can go ahead and use this in production today. It's safe, as safe as the latest version of anything is going to be. But again, built around .NET Standard 2.1, and the only place where you can get C# 8. So I'm guessing most of you are going to be C# programmers if you put your hand up in your .NET. So you can't get that. You'll either wait for .NET 5 or leap into .NET Core. It's going to be up to you at that point. You can build WPF and forms now since version 3. So that's pretty nice. And the subject of the talk is that it supports Raspberry Pi, which is cool. I like that. So Microsoft's .NET open source journey actually started ages ago. Back in 2001, they sat in a cold, dark room with HP and IBM and thought that there must be a way to be able to make a cross-platform programming language that you literally can lift and shift, and take anywhere. And then in 2002, the first version of .NET 1 was released, which wasn't open source, but Mono began, which implemented that same version of .NET Framework. Mikel de Casca, however you pronounce his last name, he was involved with that project. ASP.NET MVC was open source in 2008. Obviously, stuff happened between 2002 and 2008, but these are the key points. 2014, this was massive when they open sourced Roslyn, the .NET compiler. That was a huge moment. People didn't believe what they were doing at that point. .NET Core was begun in 2014, so the whole project, and then Mono was brought into to Microsoft then in 2016, which really signaled Microsoft's intent to really go full bore at open source, which was a really good idea. 2017, we got .NET 2, and everybody was happy. And then pigs started flying here because they open sourced WinForms and WPF, which was crazy. This is their property. This is what they've been hanging on to for all that time, and now it's open source. So, people really did believe at that point. And then now we have version 3.1. So it's all pretty good. As far as running on a web server is based, this is where .NET Core was targeted originally, was that version 1, the first version, had next to nothing in it, apart from just dealing with web servers, because they didn't want people to be sort of server locked into Windows Server and stuff like that. They wanted to target Linux. But yeah, today, that's the sort of improvement from 1,000 to 20,000 requests a second, that's just numbers, but still sounds good. These are the numbers for .NET Core 2. So you can see, what is it, down here somewhere, a heap, over 500,000 of active. So that's going to be way more now, because that's a year ago, isn't it? 2 years ago now, in fact. So I don't have the numbers for what .NET Core 3 is, but we're going to be in the middle of that line somewhere. In fact, I looked at a report on Stack Overflow, and they were saying it's the programmer's favorite framework to use now, .NET Core. So it's interesting. It's dead easy to start with. In fact, you can actually start online with this crazily named www.net. You want to go there. There's try.net as well, which is just try.net. Yeah, don't just go there. And you can do it all in the browser, which just saves you having to install all the dependencies. Certainly, if you're a little bit scared of that, obviously this isn't going to get you very far, but it can get you some of the new language features in C#8 if you're interested in those. And assuming that you've installed Visual Studio 2019, then you'll get all of the .NET Core bits and bobs for next to nothing. The only thing you don't get is some of the Blazor templates, which you've got to install separately, but I'll show you that later. So if I can actually zoom in on this, you'll be able to see. 28. Oh, you see that all right? You'll know if it's working because you can do .NET --info, and if you scroll up, then we see I've got 3.1.1, which is the very latest. Well, it's not the nightly, but it's the latest released version, which is handy. So I can there won't be very much typing. This is about as much as you get. So we do a .NET new, and then we're going to do a console app. Who's made a .NET Core application? In fact, who's using it in production? Anybody? Wow, nice. That's awesome. So that's just created me a basic CS proj and a program. I mean, I could show you what's in it, but it's not particularly complicated. Everyone see that all right? If you don't understand that, go home. Or unless you don't know programming, in which case, please stay. So yeah, that's not doing very much. But it's hello world, quite literally. So to run it, we do .NET run. And at the bottom there, then we get Avast popping up. But we get hello world. So it's pretty easy from the command line. Obviously, you can do all of this in VS as well, but that would have taken a lot longer, actually. To be fair, if I'm going to do anything bigger, then I'm going to be in Visual Studio or VS Code at least. So that's good, but you didn't come to see it running on Windows. So here's a putty instance. Everybody see that okay? One bigger, okay. We can do that. Let's go 2, just to be sure. Look. There. Yeah? Cool. So let's do the same thing. I'm running this over my hotspot because I'm scared of public Wi-Fi. So it's not going to be as quick as Wi-Fi at home. So any speed problems that you see are generally just going to be because I'm hotspotting. And there's one there, look. So again, I can do .NET --info. You can see that's working. I've got the same version, 3.1.101, and I can do exactly the same .NET New Console 1. None of this is a surprise. You want .NET New Console? Ah, yeah, you're exactly right. Aren't you good? Pair programming. Ah, it's slow. No. This is a Raspberry Pi 4, and it's massively faster, actually. Stuff that was taking 45 seconds takes 6 seconds now. I was moving from 3 to 3.1 as well, so there's going to be some improvements there in the build engine and stuff, but I think most of it is the fact that it's about 4 times faster, and it's got 4 gig of RAM, because you choose the biggest.
And on top of your Raspberry Pi, do you have any shields or?
No, just a bunch of cables. But you can plug a bunch of stuff in there, although you're going to be coding a lot of it manually. Certainly.
Your LEDs and stuff like that you're showing working, are they extras or?
Oh yeah.
Built into the product?
Oh yeah, no, they're extra, yeah. But cheap as chips, you know. You buy them off Amazon, then less than a £5 will buy you enough to get you going for a good long period of time. On their run. Oh. And then hello world. It's slightly slower, but it shouldn't be massively there. I mean, no, it's not doing much, but actually behind the scenes it's doing a fair amount. So this is, I've got the full version of the .NET Core framework installed on there. So if I flip back to my slides. To get it on there is this, which is why I'm not showing it. And you've got to wait for a lot of that stuff to happen. The bottom part of that's firing up Blazor, but half of that is just getting it installed. And no one wants to sit and watch me do that because it's not very interesting. But all of the instructions are on that link just there. So if you go to that, then the slides will be made public, so you'll be able to get all these anyway. So you can follow along with that. Most of it's stolen from Scott Hanselman and Peter Shaw. I just wrote up what they did and put pretty pictures around it and made it a bit more understandable. But a lot of their stuff, I mean, Scott Hanselman's was all .NET Core 2, and Peter Shaw's stuff was all preview stuff and just a notepad file. So I tried to make it a little bit more understandable, mainly for me, actually. But yeah, so you need to update your Pi, which is obvious, but they're the update commands in case you don't know what they are. Then what I've done is set up a shared directory, and I'll show you that you don't actually need that. So you can install Samba on your Raspberry Pi and just do normal file sharing like you would Windows to Windows. And then you've got all of these steps to install the framework. So there's a couple of prerequisites, a couple of libraries that aren't included in Raspberry and that are needed for the .NET Core framework to work. There's no apt-get .NET Core for a Raspberry Pi, only supports 64-bit systems, which baffles me actually because you can do it, it's quite easy to do it. So I'm not quite sure why they haven't just gone ahead and done it. Yeah, then you download some binaries. Again, there's no installer. And then the ASP.NET Core runtimes. And then you have to symbolically link all these things together then so that everything can see it. And that only works on that current session. So then you've got to, right at the very bottom, you've got to stick it in a bash file so that every time you reboot, all that happens automatically. But you only need to do that once, theoretically, unless your Raspberry Pi dies. But then you've got the instructions, so you'll be okay. It's easy. And then you can check it works, which I showed you in .NET --info. So it's all good. So we saw that console app, but that's boring. So really what we want to do is make an LED flash. But before I do that, I'll talk a little bit about GPIO. So not many people put their hands up, so it could be quite valuable to go through this. So that's general purpose input output is GPIO, and that's referred to on anything from a Raspberry Pi through an Arduino and a Feather M3 and anything like that will all have something that can drive an LED, you can see it top left, or something that can read a button in the simplest form. There are a whole heap of other things on there like SPI, serial protocol interface, and I2C, another serial interface, and heaps of different stuff. It's got analog bits and bobs on Arduinos as well, but the Raspberry Pi does what it does. So what I've done is made that little circuit there, and I've connected my LED to pin 10 and my button to pin 26. It's worth bearing in mind when you start this that there's two different numbering schemes. So you can see right here, that's called the board numbering scheme for obvious reasons. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. So that makes sense. And then there's this BCM numbering scheme, which is sort of a legacy thing that they took over. There's actually another one called wiring Pi, but you don't need to worry about that so much because unless you're going to do Node, if you're going to stick with .NET Core, then these are the two things you're going to be using. And I'll point out that bit of code later on. Yeah, you're going to use this NuGet package, the .GPIO NuGet package, and I'll add that to my console app and copy and paste some code in and make that run in a minute. But it supports Raspberry Pi and a whole heap of other systems. I've not used any of those other ones. I'm happy with the Raspberry Pi. It also supports Windows 10 IoT. Has anybody tried playing with that? Yeah. I actually made a robot out of Windows 10 IoT when they first did it with an Xbox controller and everything. That was my first ever talk, was demoing that. Yeah, so you can install it with the CLI or with a package manager if you were to do it with Visual Studio or something like that. You can find out a bit more information about what it does with that link there. Again, links will be in the slides when I release them. So, an LED app. I told you I set Samba up so I can see my files. Can I zoom in on this? Not very easily. But trust me, they're all there. They're my folders. And I created a console1 folder. And in there I've got a bin folder, an obj folder. I've got a bin folder because I ran it So just like any .NET app, you're going to get a bin and a debug folder. It gets a little bit more complicated than that, but that's the basic idea. And I can open that in VS Code and see my program, which is just that standard hello world at the moment. Not particularly complicated. But what I want to do in there is I want to, let's just get this. I need to add a package, this package just here. Does anybody use the command line for their .NET Core, or are they stuck in VS? Oh, good. That's a good spread of people. I'm not a massive command line fan because my memory is awful. So they're trying to remember Git commands. Oh, bugger it, I'll just use VS Code and it just does it for me until it's something that VS Code can't do, and then I'm knackered. So I can run that command here. So I'm going to add that GPIO package to my project. That won't take very many minutes. Hopefully not minutes. Done. And if I flick back to my program and get rid of all of this and replace it with the code. There. So what I've done, I've added a reference here to GPIO. It's complaining, but it's added my reference in this CS project anyway, so it is actually there. Well, I'm hoping it's there. So that's the using for that, and then my code starts after hello world. So I've got a GPIO controller, and you see now I'm choosing the pin numbering scheme, choosing the board pin numbering scheme, because it's the easiest one to understand. At least I can count, rather than having to get some document out and then count twice. My LED was connected to pin 10, and I've got a timer here. So I'm using system.threading because I'm going to be using a thread.sleep. But I open the pin down here on line 18 and set it to an output. So this is a pretty standard thing in the world of IoT, is opening pins. You'll do a similar thing if you've played with Arduino. You'll tell it to open a pin and which direction you're going to do it in. So we're going to open that pin as an output. Makes sense. And then I'm just going to sit in a loop, and I'm going to write a value to the pin, telling it to go high, and then wait, and then telling it to go low, and then wait, and then just loop. And then when I exit, it's going to close the pin because I'm a good programmer. So if I save that and flick back, we can run .NET build, of course, to make sure that that's going to work, because that could still break. Hopefully it'll build. Ah, good. That's what we like to see. Green, no red. And then run. And then hopefully, if I switch this on, leave that in the way, and when it's finished, and we have a flashing LED. Right, I'm off to the pub. I'll see you later. Yeah, sometimes that doesn't work. But no, that's good. So that was a bit of a faff. And you don't really want to have to go through that whole process time and time again on the Raspberry Pi. Once your application gets bigger and bigger and bigger, you're going to run out of processing power to sit there running out of waiting power to sit there waiting for it to build more than anything. No one wants to sit for ages and ages. You've got a powerful PC that you're dialing into a not so powerful computer, so don't do that. So you can actually do all of your development just in VS Code, and you can debug it, which is pretty cool. So if I close out of this lot, don't need you. Magic of, here's one I prepared earlier. There's a GitHub repo, and I think I put it in the slides. If not, I'll add it to the slides before I upload them, with all of this code in, and it's not particularly complicated, so don't worry. And in fact, it's pretty bad in places, because later on you'll see I had to do some fudges because the debugger wouldn't work with some of it, so I had to make it work really badly. So when you look at it, it'll be like, this guy's a bloody crazy guy. So this is the same code. No difference whatsoever. But what I've done, and this took me ages actually, and they say that there's plugins that can make this work. Like there's a remote development plugin for VS Code, and I've got it installed. That's what this is, but I couldn't get debugging to work with that at all. And I spent the whole weekend then trying to make Scott Hanselman's 2.0 debugging work, and that didn't work either, but it did after the whole weekend. So I was quite proud of that and immediately committed it to my GitHub repo in case the world ended. But the idea is that I've got this .NET Core launch task. Now, has anybody played with launch and task.json in VS Code? It's that good, actually. You can pretty much do what you like in there once you understand how the syntax works, which will be never, actually, because it's a sod. Actually, it's escaping bloody quotes that's the biggest problem, actually, and where it wants them escaped and where it doesn't want them escaped. Which sort of quote it wants. Yeah, I nearly killed myself doing it. But it's using putty and p-link here to open an SSH session and attach the debugger through that SSH session, which is pretty cool, actually. It's not massively fast and not ideal, but it works quite well. Hopefully they'll release some nicer first citizen tools for that. But you can see here that it's going to do this Raspberry Pi deploy WSL pre-launch task, which you'll find in tasks.json. So I'll scroll to the bottom, almost, because there's a few experiments in here that I did it with a bat file originally, and I thought I'm not going to have to include a bat file in every project because that's just not pretty. So after the weekend was out, I managed to figure it out. So we have this WSL and here, deploy. Actually, we start with that one and go backwards. So we've got rsync. Has anybody used Linux? Has anybody use it day to day? Has anybody used rsync to be able to synchronize files between two platforms? No, I'd not used it much until this weekend either, which didn't help me that much. But yeah, the idea with it is that it will compare your list of files against the remote list of files and only copy the updated ones, which is dead good. If you're just going to do the other version, which is up a bit further, SCP, then it just copies everything all the time, and that takes ages. So I wanted to get rsync to work, but for some reason it was just a nightmare. Actually, I could get it to work in Bash, in the Windows subsystem for Linux thing. I get it to work in there, but I couldn't get it to work in this task thing. So highly frustrating, and I treated myself to several pints of beer after I got it to work. But yeah, so this SSH pass part here, rsync doesn't take a password generally, so it was prompting me every time, and I didn't want that. So obviously I've not changed my password because, you know, who does? It's a Raspberry Pi. And that just feeds that into this rsync command with a bunch of stuff that says only do the updated ones and create them if they're not there. And I'm taking this directory here, my workspace folder, which in this case is .NET Pi 3, I think, or something like that, and then just going into this publish directory, and then this is the current IP address. What I'd like to be able to do is make all of these environment variables, but for some reason that didn't work either. The bash wouldn't accept the environment variables, so there must be some way of being able to feed those two together. So if anybody's got an idea on how to do that, then submit a PR to the pull request. Don't wait till next October, by the way, because I need it before that. And then it just takes a base name. Here it's where it's copying it into that directory, a shared directory that you saw earlier, and just creating a directory from a project there. But this one relies on the publish, depends on, which is quite handy. So you go back up, and this is doing the publish, and it's telling it to do a Linux ARM build. And it's putting it in the publish directory. And it itself depends on build. So you need to obviously build it first, and that's this one right at the top. You'll get build generally as straight out of the box, so you don't need to worry about that part. But again, this is all on GitHub, so if you do come to do this, then you can just copy them same files and then just replace the IP addresses and host names, and you'll be off and running. So, I mean, that's the basic. I wanted to show that at least because it's not straightforward, and certainly if you look on the internet, they just say, oh, you can just use X, and yeah, it's not as straightforward as that. So my program, and over here then, in debug, we have various different launchers, including my remote console one, so make sure that's selected. And then I've already deployed this, so it's not going to deploy all the files, but if it did, down here at the bottom, in a second, so that's the build task it's just done there, and now it's doing the publish. And now this is the part where it's going to send a bunch of files over. And so for some reason, it always thinks that those two files changed. So we've got hello world, and then again, if I swap back over to my camera, I closed the camera. Nobody told me. It's probably going to be my chin now. Oh no, good. So yeah, that's it working. But I mean, that's working directly from VS Code, so you don't need to leave your coding environment there. It just works. But obviously, I can stop it and scroll down, and then over, let's do it here. I can stick a breakpoint in, and if I run that again,
what's going on here? You built the code on your PC and then deployed it to the Pi.
yes. Yeah. And then using that P-Link, it's invoking that application. You've got to install a VS debugger. It's just a single line on the target operating system, the Pi in this case, and then it invokes the application through the debugger together, and so it knows the port that comes out of that, and then it attaches the VS Code debugger to that process. It's clever, really, and I didn't figure it out. I just kind of figured out how to get it to work there. But there it's stopped, and you can see top left-hand side, look, I've got the variables have been pulled in automatically as well. So this is dead good for debugging, certainly. Trying to debug any sort of IoT is a nightmare. And if you've done any Arduino stuff, then it's almost impossible without JTAG and stuff like that. And oh, yeah, and it's C. Oh, God. So this was amazing when I got that to work, because then that really does open the door. Although there seems to be some bugs. I couldn't get it to debug Blazor very well. It was just crashing. But for the most part, this is working. And now you can just copy and paste those two files, and you can do it too, which is cool. So obviously, that's a nice bit that we can do now. So we can live in this now. So I can close that one, and I've got all of my code sitting in this directory. And the next thing we need to do is look at a button. And I'm not going to sit and spend ages running through all of these little tiny bits. But you should always get a button and an LED working, otherwise it doesn't work, and we need proof. So let's get this out of the way a little bit. So I've got rid of the threading part here because I didn't need it. I'm not doing any delays or anything here. We've got the same hello world, and I leave that in there just so I can see it pop up in the console, and I know it's just not got caught in some strange loop somewhere. So it's good to have some console logging in there anyway. Same controller, but now I've got a button pin, and I'm opening two lots of pins, the same LED pin, but also a button pin. And you'll see there, that's an input pull-up. So does anybody know what a pull-up is? So exactly like John says, that you've got two ends of the circuit, but if you just connected them in there, they could just float around. Generally, you need to pull one end of that button up, as John just said there, so that it's always one at that particular point, pull up to one, and then when you press it, the circuit completes and it goes down to 0. So the end that's looking at the button's either going to see a 1 or a 0, depending on which you're looking at, but it's kind of backwards. And an LED is kind of backwards with the way it's wired as well, so you'll see that. So we've got a similar sort of loop here, and we're looking to see if the button's false, but we're going to set the LED to be high. Because as John's just said, when you press it, so when you press it, then it's going to go low, and we're going to set the LED then to be high. So the whole thing seems a little bit backwards in case you look at it and go, what's it doing? And then if nothing's pressed, then we just set it to low, and then I close the pin. Actually, look, see, I should close the other pin as well, but I'm not that good. So I'm going to run that one and just show you. Oh, well, in fact, let's see if I've remembered. See if it remembers rather to use the right deploy. It might do. Yeah, it is. That's the right one. So we should get that same set of steps. Flick over then to the debug console, all being well. There we are. Then we should, oh, hello world's gone. That's gone up there. And then if I press my button, then, oh, the world's most complicated program is running. The LED comes on. Could have just wired it straight up, dude. But that's cool. Yeah, that's true. Here, look what I made. I made a battery. Yeah, so once you've got those two things working, though, I mean, you're off and running. You can read inputs and you can set outputs. So you can pretty much do anything you like. Obviously, there's other things like PWM that you probably want to start looking at if you want to make robots or servos or anything like that. But as far as the basics are concerned, actually, I've got redundancy there. That green LED in this talk, you will never see that light up. In fact, put your hand up if you do, and you're going to win that green LED. So it should never come on. Something's gone disastrously wrong at that point. So that's a basic. I closed it again. Why didn't anybody warn me? In fact, I don't need it, and that's why. That's the basics. But I've made OT there. I've not made the IoT. There's no internet involved in that, other than the fact that maybe this is going to be on YouTube. So I close this one down and go back up. Who's played with Azure generally? Oh, good. A fair few of you. I guess you're going to be going to the Azure meetup next week, is it? Who's played with IoT Hubs? Oh, one. How did you find it? Did anybody else put their hand up? I only saw one.
It's good, great fun.
Yeah, cool. I'll show you, being as nobody aside from yourself has seen it, I'll show you how that works. So, IoT Hubs. Basically, they're like a big switchboard that you can connect millions of IoT devices into and send messages. And then you can take those messages and you can put them onto a bus if you like. And then another service in Azure can take information off of that bus and do something with it. So say you had a temperature sensor like a Nest or something that was sending messages up to the cloud. You could take those readings and say the house temperature went up to 35 degrees. You could have it automatically ring the fire brigade or something like that. You can quite literally do anything once you've got it there. I made a little system that would take the temperature and look at two margins, and if it went over a certain temperature, it would read that and then send a tweet out saying, warning, the temperature's gone over a certain threshold. But again, once you've taken those messages and you've stuck them in the cloud, then the world's your oyster at that point. You're ingressing stuff into Azure. You can do what you like with it. I'm doing Azure because I'm an MVP, so it's kind of a responsibility to do that. But hand on heart, honestly, that's the best. AWS is pretty close, but the docs are terrible in AWS. So, but it does work. I've done talks on AWS's version of that, and it does work quite well. But yeah, the whole infrastructure around Azure in that particular area is ahead, in my opinion. So we've got Azure Devices Client here, which is a NuGet package again. So that's going to handle all of we don't need to write the code for the most part. All we need to do is just pump in the right information. So if I get rid of that, give us a bit more space. And again, shout if you can't see everything. But to connect, you need a connection string, funnily enough. And that takes a host name that you get to choose, and I'll show you that in a minute. And then this section at the end, the Azure Devices.net, is always static. It's always the same thing. And then we get a device ID and a key. I'll change that before this video is published. It's on the free tier, I think, anyway. Doesn't matter. And then we make a device client, and the device client's the thing that we're going to use to talk to Azure IoT Hubs. I've got the normal hello world just to make sure everything's working. And I create a device client by pumping in my connection string. And then I've got my same controllers here because I was lazy when I wrote it, so I just left everything else in there. But the idea is that when I press a button, so that's that same code that was and still is lighting an LED up. But at that point, I call into this send device to cloud message async. All the rest of that above is the same. But I say button pressed, and I just convert that to ASCII. That's what all that line's doing there. And then I add a property, because you can add all sorts of different stuff to say the button was true at that point, which is obvious because it's sending the message. And then I send the message, and then wrap it in a try just in case the internet's off or something, and then console log out the fact that I've sent it. So I've already created an IoT Hub, so I'm just going to run that, and then I'll show you how you go about creating it. So make sure I'm in this. Yep. This will take ever so slightly longer to build, but again, I've deployed this already, so it shouldn't have to copy the files. It's when you see that line at the top, the SCP line, that you'd see a whole heap of files deploying. That can take, I don't know, it took my Blazor app about a minute to deploy, but that was on the hotspot. So if you're on decent Wi-Fi at home, then I'd expect that to be better. Raspberry Pi 4's got nice fast Wi-Fi. If you've not played with that, 4 gig of RAM and dual 4K HDMIs and USB-C and gigabit Ethernet, and yeah, it's pretty capable for 50 quid. Not bad at all. So I think that finished. It didn't stop, did it? So that's good. So what I've got is this application here. Oh, no, I'm not going to zoom it running. Zoom it. Ah, that's better. Now you can see that, yeah? So this is, if you install the IoT Toolkit SDK, then you're going to get this application with it. And it is what it says on the top. It's a Device Explorer Twin. So what this is doing, it's monitoring the messages that are hitting Azure, and it's just going to show them. So if I go to Management, it can see my various different devices. So I've got a bunch. So you have an IoT Hub, which is like the switchboard at BT, and then all of the devices connected to it, which would be if you like, the homes connected to those telephone lines. And you register as many of those as you like against that. And they can all talk simultaneously and not a single message will get dropped. What your application does with all of that telemetry is your responsibility after that. But if I go to data here, then this is the one that's going to monitor those messages hitting the IoT Hub. And I'm looking at my Raspberry Pi. So that was, if you remember, the device ID that I had back over here. Oh, there we are. So that's my device ID there. So those two things need to match. Generally, when you're developing this lot, then you're going to be doing it with a single device. You're not going to have multiple on there to begin with. So you don't need to worry too much about that. It'll just auto-populate that. And I can hit the monitor button. As long as everything's working, then it'll say receiving events. Now, I'm going to flick back away and just watch what it does. When I press this, it loads a whole heap more stuff and creates a whole heap of threads here and everything. And then it says it's sending the message because the button's been pressed. And if I flick back over, then we can see there's the data. So that's gone from my Raspberry Pi through my hotspot up to Azure, and then my laptop is then able to receive that by polling the messages that are sitting on IoT Hub. So I mean, that's pretty powerful all on its own. And so you could have hundreds of those all sending telemetry up, and you can then do what you like with that. I mean, this is the simplest implementation you could possibly imagine for this, and not very practical, if I'm honest. You really need to be putting that onto a bus, and then Azure Functions or some other sort of web app or something like that sitting there in Azure, and then you can pull that data and do something with it. Power BI or something like that. So that's good. We like that. So I'll quickly show you how you create one of those. So if you go to portal.azure.com, I shall try and zoom in when it starts. Is that zoomed in enough for everyone? Cool. So it's dead easy to create a resource. There's a big plus button that says create resource. And then you can search, and there's so much in here, and then that's not everything, obviously, but it's an Internet of Things category in there. You can go browsing through that if you like. But the best place to start is there. You can just type IoT, and you can see we have IoT Hub and device provisioning and intelligent edge and IoT Central and stuff like that, but we're interested in an IoT Hub. We can create one of those. So if you've got an Azure account, then you should be pretty familiar with a lot of this. You know, choose your subscription, pay as you go, or I've got Visual Studio Enterprise there. Create a resource group. I'm going to do one just for the fun of it, .NET Oxford, so that I can kill it later. It's always a good idea to do resource groups. Then again, I'm preaching to the converted for at least half of the audience there, but a resource group is a folder that you can put all of your resources in, and then say you're doing a talk like this. At the end of the night, you can just go delete .NET Oxford, and Dan starts crying. So that's .NET Oxford, and then choose a region close to you. Now, regions aren't, again, sorry for the people that already know this, but regions aren't quite as straightforward as choose the one as close to you as possible. There's certain regions that are going to get all the new stuff first, and obviously America is going to be one of them, and West US would be another one of them, obviously, in there. But Western Europe and North Europe, there we are, North Europe there in particular I tend to use, because that gets a lot of the new fandangly stuff quite early on. Pricing changes between all of these places as well. You can imagine if you're going to choose London, there's going to be more people wanting to use London. So stuff like that, it's worth bearing in mind, but for the purposes of what we're doing here, it doesn't matter. Give your IoT Hub a name. So again, this is the exchange. So I'm just going to call this .NET Oxford Hub. And then you could just create this straight away, but it's going to choose your defaults. And if you've ever done anything in Azure, don't ever accept the defaults because it's the one that charges you money. So in size and scale, see, look, standard tier. There's actually a free tier. Now, I'm not going to be able to use it. In fact, it might complain later, but you can only have one free tier of IoT Hub in your account. So you can still have most of the stuff that's in there, you just can't have everything. But just go away and have a look at the different grids to see what you do get with free tier, but you'll be able to do everything that we want to do here with the free tier. I'm not going to do that because I think it's going to complain. If you do choose a standard tier, all of this is billed on the number of messages, and I think it's 400,000 messages that you get free in a free tier. But you get these in blocks. Now, messages are 4K. So if you sent an 8K message, confusing terminology, I know, then that would take up 2 IoT Hub messages. So just bear that in mind. If you've got lots of messages going or lots of big messages going, then you need to start looking at how much it's costing you, and you can switch scales, and that's what these are doing for the most part. Basic tier and standard tier, the difference mainly between those, I think, is whether you can do device provisioning service and stuff like that. But yeah, these are the same cost, but it's just sort of front loading where that cost is. And then you can have more of these units up to a particular point. If you chose S3, but look at my cost per month. Should I press create? Yeah. That would be really, really bad. But you can sort of see what's happening. So if I go on the free tier, you can actually see down there at the bottom, actually it's 8,000 messages, look, down there. But 0 cost, so, can't complain. But yeah, 400,000 messages on the standard tier and only £18. So 400,000 messages at 4K each is a lot of data. So even if you do want to have a play, then that's still quite an affordable way of doing it. You could have a heap of different devices connected to that and never hit any problems. Pretty cool. So I'll leave it like that. And then review and create. So I implore you, please always check this, because the number of times that I've done this and then I've forgotten I've changed something and pressed that, and then you build and it's bad. So just make sure that that's exactly what you expect, and that is. So I can hit create. And then that creates. This whole process has improved in the not too distant past. It used to be before that would just disappear and you'd never know what was happening, other than clicking the little bell and then it pretty much telling you what you already knew, that it was doing something. But when this finishes, it'll automatically tell you that it's finished, and in some of them it'll even take you straight to the resource as well. I'm not sure if this is one of them.
So mentioning that VS Code's got a really good extension.
Yes, it has. Absolutely. Not so much, but yes, I'll show them. Yeah, exactly. I've got them all installed. Yeah, good point. So, yeah, sorry, what was your name again? James. James has just pointed out that you can do a lot of this in VS Code and Visual Studio as well if you want to, but VS Code's just way easier. You can just install an extension and you can manage a lot of this stuff. So the Device Explorer Twin application that I showed you, there's a version of that that runs, although not as nice in my opinion, but it runs in VS Code. So again, that keeps you in your development environment rather than needing to keep using lots of different applications. So you can manage your devices in there, you can get device keys and connection strings, create new devices, kill new devices and stuff like that. So has anybody got any paint they want to watch dry instead? Oh. It's usually quicker than this. America's online. We're all watching Trump get impeached. Come on, people are waiting. Sorry? Both. Deploy the Trump impeachment service. While that's deploying, because we don't need to sit and wait, because I have one I prepared earlier. Oh no, and now it finished. It heard me. It knew, no, don't go. We have a go to resource button, so it didn't take me there automatically. So down on the left-hand side, we have a heap of stuff that I'll collapse in a minute. But the overview is always quite handy. You've got the subscription ID in there and pricing tier and your host name. So you remember that from earlier? That was in my connection string. But there's a few things that you need to do. if you want to get things to work properly. This application here requires a certain amount of configuration and it needs a connection string. And because it can see all the devices, or you want it to see all the devices, it's going to need access far higher than a device would do. So you've got the IoT Hub level shared access policy, which is here. So if we go to shared access policies, then we have a few built in, and you can go ahead and use those if you like, but don't, because if you ever need to revoke one, you don't want to revoke the IoT Hub owner, because that's the only one of those you've got. So you can add a new one. And this is effectively the keys to the castle, so you just make sure that you don't give this to anybody, but I'm going to call this Device Explorer, and I'm going to give it access to everything. There we are. And then that's remarkably fast compared to everything else that's just happened. So that's creating that shared access policy. Oh, look, it's not remarkably fast. You heard me say it. I can't imagine. Oh, there we are. There we are. Update is successful. And there's my Device Explorer at the bottom. I think that actually appeared before it said it had finished. So that's telling me what I've just set up, but we've also got shared access keys, primary and secondary keys. You can take those keys and you can build, and in fact you do build your own connection string using that, because certainly when you get down to the devices, it's only that part that's going to change and the host name. But we have a connection string and we can copy that. And then at that point you would, and I'm not going to, paste that into this application here, or if you're using the VS Code extensions, put it in there. And then once you've got that, then VS Code or this application can manage your IoT Hub on your behalf at that stage. But what we don't have at the moment, like I have previously set up, are any devices. So you may have seen when I was scrolling down there that we have an IoT devices category. If I click on that, then we don't have any. Surprise, surprise. But I can create a new one. And it wants an ID. And just to mirror what I'd already done, I'm going to create a Raspberry Pi. We don't need to worry about keys. We'll just let that sort itself out and auto-generate them. It used to be that these were disabled by default, and that was the cause of a lot of people's problems when they first started doing this. It'd take ages to figure it out, because of course you've got several layers to go through. And it indeed happened to me. You can set a parent device just in case you want to have devices layered there. It's a different sort of an idea. I'm not going to go into that in any detail. But if I hit save on that, then that was quick. We now have a Raspberry Pi. If I click on that, a little bit like the shared access policy we saw earlier, each device will get its own connection credentials, and we have a primary connection string. The reason why you have two is in case one's compromised and you need to just swap them. And there's a protocol you can go through to swap your two connection strings and then create a new secondary one, essentially. So somebody walks off with your Raspberry Pi and it's not encrypted in any way, then that's the sort of thing you might end up doing. So this is then the connection string that you choose, and I'm happy to show you that. So it looks very similar. So that's .NET Oxford, and there's that same Azure devices.NET, and the device ID is Raspberry Pi, and then that shared access key, which is the same as up here. So that should be the same code you can see there. And that's what we stuck in here. There we are. So that's the connection string that we just fed into that. So with this demo code, you'd have to go through those steps to create, but there's about 6 million YouTube videos and even more blog posts on how to set a device up. And it's not, oh, just watch this video when it's released, and you'll know then. And just copy and paste those bits in, pretty much just that. And then you'll be off and running. So yeah, that was essentially sending a message when we pressed a button, which is nice. But again, we're sort of only a part way there, because that's one-way communications, but IoT Hub allows two-way communications. So not only can I send messages and telemetry up to IoT Hub, we can send messages like, can you please tell me what your readings are, down to the IoT Hub. So if we stop that, my imaginatively named projects, that was out, and we'll look at in, whoops, this one. Pi IoT. This is the one that I had to frig around with to get it to work. Possibly part of my slight ignorance in how to do async await properly, but anyway, let's not go into that. Most of this is exactly the same, but I brought back threading because I was doing a little bit of delay work. We've got the same connection string and device client that we had before, using that device client and the connection string to create a device client. Same GPIO controllers. This is the part that I had to fudge that I'll get to in a second, but we've got the same send a message to the cloud. But down here, so we've got a while loop, that same while loop, and I'm just checking to see, and there's got to be a better way of doing this, but it's a demo, so it doesn't matter that much. I'm checking to see if there's any messages, excuse me. So receive message is not equal to null, then I'm going to do something with it, which is literally just convert the bytes into ASCII and squirt it out into the console. So if I run this, does this all make sense, by the way? No one left yet, so it's not that bad. Hello world zooms past. Now this part takes a little while for it to actually catch up. It's faster when you're not debugging it because, as you saw when I press the button, it has to bring in a bunch more stuff. But when it's receiving a message, it's got to bring in a bunch more stuff before it actually shows it. So you'll see the delay. But back in our little program, we have a messages to device section here. And I'm telling it which device I want to send the message to. So it's a bit like which device do I want to see the messages from. We can tell it which one we want to send it to. All of this is available in code as well. That's the whole point. This is just the code is available for this application. It's all open source, so you can take that code. It's all in C#, and you can then build it into your own applications. But all of the docs are really good around this, so it's not too hard. So we have the device and then a message. You can send some properties with the message as well if you like. We won't. You can see I've sent some earlier. Spoiler. And if I press send, and it says it sent it, and then if I flick back here and get rid of that, there, received message, hello. Actually, it worked faster than it did earlier, so I'm happy about that. It took it about a minute, and I thought it wasn't working, and then I got like 4 of them and some swearing. So yeah, that's really bad code, and you can see why it's really bad code that I've written, because now I've got a whole heap of threads running. It's spinning up all of those async await stuff, and that's bad. So again, if you can figure out a better way to get this to work with the debugger, because my original code just spun that up and had a while loop here, which was fine, because then you only got the one thread. But that's the actual demo code online was the version I was running there, but it wouldn't work with this debugger. It just got completely stuck. It's like it was trying to run it all synchronously, and it was just getting caught in this async task, which is just bonkers, because that's not how it's supposed to work, surely. So yeah, I had to hack it together to get it to work in the demo. But yeah, that's IoT Hubs. So that's the circuit part finished. Oh, boo. So if I stop that code, otherwise things get confusing. I'll switch back to my slides. So yeah, again, does that make all the sense in the world? That is not overly complicated. There's quite a few steps in there, but it's all broken down nicely that you should be able to just pick that code up in GitHub and hopefully just have a go with it once you remember to change IP addresses and host names and IoT Hub names. And yeah, it's not that easy then, but it's not too bad. So we did remote deploy and debug, and there was our circuit that we had with the LED and the button connected, and we made a button app, and then we did some IoT Hub stuff, which was cool. Now we can talk a little bit about Blazor. C# rather than JavaScript, which is great for, well, everybody, actually. But yeah, it's dead good. It's a client-side framework, but it started life as Steve Sanderson, if you've heard of him, is a Microsoft employee. It's his little pet project. Again, based in C# and it replaces the JavaScript element that runs in the client there. It's Razor, so same ASP Razor syntax is very similar to that and HTML. You can do server-side, and I'll kind of go into that, what the differences between these two are, and then client-side WebAssembly. And it's plugin-less, so it's not like Silverlight. Theoretically, they're not going to kill it. They say that this is the future, and I can see why, because it just seems to be working and everything's in it. In fact, I think isn't part of Stack Overflow in Blazor now and all sorts. So it's getting in there now and supported in, I'd say, all modern browsers, really, because if you're not using one that's not supported in, then, or if you are using one it's not supported in. And it runs on a Raspberry Pi, which is cool. So I'm going to do this live on here. Good, that's that. So we do .NET, new, and then Blazor server. This is the most rubbish example in the world, but it's just a proof that it actually does run on a Raspberry Pi, and it runs quite quickly as well. So there's that. There's a little bit of stuff that you've got to do if you're going to run it on a Raspberry Pi, though. The www root folder is the main folder to worry about in there, and it's not got very much in it at all at the moment. Again, you can do this on your PC and deploy it if you like. It's just I couldn't get it to debug. So there's a bit of switching around. I just wanted to show how easy it was to get it going. So I have a program.cs, and that's going to be doing most of the setup for the application. I'm not going to deep dive into Blazor because this is not a talk on Blazor, but it's just a proof that it's performant enough that you can run it on low-powered systems like that. So this whole section at the bottom here creates the application, but it's looking for local host when you do it. And if you type local host, then I'm going to get my PC. And if I type the IP address in, it's not looking for anybody else on the outside. So if hopefully I've got it in here somewhere. Oh, I'm going to have to go and find it. See, if you go on my blog, then scroll down, oh no, scroll up to the top. There's 4 parts to this blog series, but the Blazor example is the very first one. And that's all the setup instructions I showed you there earlier. So doing your update and those prerequisites that I talked about, and then binaries and ASP. See now. ASP.NET binaries and runtimes and stuff, and then doing symbolic linking, and no one wanted to watch me do that. That would have been terribly boring. But you need to do this section here, which is just getting the Blazor templates. If you don't do that, then you're just going to get what it comes bundled with, and you can see that they're actually in preview, some of them. And they're in preview for the WebAssembly section mainly. And then there's some other stuff, scaffolding apps, .new Blazor server. And then this is about the only part that you need to remember. Look at all of this. But down here we need this line which just says, please accept connections on port 5000 from any IP address. So that star that we can see in the middle, just here, that's telling it that it can accept it on any IP address. Now, you've probably all done that before, but I'd not realised I needed to do that, and it was quite frustrating. One line fixed my problem. So if I save that now, and go back here, let it run. And again, this is a Raspberry Pi 4, so it's actually pretty quick. You can do this on a Raspberry Pi 0W if you want to, but I wouldn't advise it. Obviously not as fast as doing this on your computer and pushing it, but it's not too bad. I promise. There, so now it's listening. And I've called my Pi MS Cognitive. Oh, look, I've been there before, and if I hit port 5000, and all being well, a little bug with my, oh no, it is doing it, there we are, and there's my Blazor app being served straight from the Raspberry Pi. And it works actually quite well. So go on the counter and click on that, and this, if you've done Blazor, then you've seen this many times. I actually quite like this as an out-of-box vanilla. This is what you can do. There's enough in it that you can sort of get going, but not too much that it's like, oh, geez, I can't even understand what you've done. It's actually pretty cool as far as that's concerned. So this is Blazor server. This, I don't know if you know, but this works by having the .NET element running on the server, as the name sort of suggests. And you have a client element that's connected to the server via SignalR. So it's just sending the UI updates over the wire. It's not sending the whole UI itself or any of the control. All of it lives actually on the server, and then it's just connected. It sounds a little bit crazy, but actually it's quite performant when it does it. And you can have, I believe, thousands of simultaneous connections in that method, and then you'd have to spin up more servers, I'm guessing, after that. But yeah, as far as the SPA is concerned, that works really well. But if you've got, actually, what you can do is if you get the developer tools open, I could have used my Zoom It to do a lot of that stuff earlier, couldn't I? Just as easy. But if I F5, so that's what's been sent over the wire there. So we've got a bit of JS that you don't have to worry about, and an icon and some CSS and fonts and stuff like that, but not that much more. So the rest of it's just been transmitted via SignalR over that socket. So that works quite nicely. But as I alluded to earlier, actually if I stop this, you can sort of see what it does look. Oh, attempting to connect to server. So it knows at that point that the SignalR connection has been broken. And that's what it's telling you there. But if I make another one of these, Blazor 2, imaginatively. If I do .NET new Blazor, I think it's WASM. Hope it is. It'll tell me if it's not. Oh, good, it is. So this is going to create the WebAssembly version of this. Has anybody played with the WebAssembly version of Blazor? Playing's fine. The next question, if somebody did put their hand up, is, oh, did you put it in production? Whoa. It's definitely preview. It's not going to be released for a good while, I wouldn't have thought. But the demos work. So now if I do .NET run, it will look very similar. Yes. Good point. I'll let it finish though, just in case. I have to do this again. Tell you what, I'll just try it. This is listening, but you're right, it shouldn't work. Yeah, so it can't reach it, so that's just sort of proof. I did that on purpose, honest. So if I open that one up, at least I don't have to scroll through my whole blog again to find that. Blazor 2. Same thing, program.cs, and then stick. Actually, oh, I don't think that's going to work in there, personally. I don't think I've actually done WebAssembly on the Pi. Let's cheat. Let's do it here instead. I would have had to do this anyway. Should be a lot faster here. All been well. I'll have to look that up and see what the actual, it's probably a dot that I've got about at the bottom of that somewhere. There we are. So that's running on localhost now, and that will work because that's just on my PC. There. But we can see if I zoom in down here, that's actually now pulling in a whole heap of DLLs. So this is running a virtual machine essentially in your browser there in the session in the browser, and it's then pulling in all of those DLLs and using them. So a completely different way of working, but it will work offline essentially. whereas the other one, when you stop it, it completely stops. And this should be way more performant than even that as well. So now you're utilising the power of WebAssembly and your client's browser rather than you having to pay for the processor cycles in Azure or whatever your hosting platform's using. But again, this is very much still in preview, but everything is exactly the same as it was before. Although you get this little prompt here. What do you reckon? No, it doesn't work on my Pi. And that's all exactly the same as it was before. So again, it's pretty cool. That's a great way to get into WebAssembly as well, of course, with C# rather than you having to do anything complicated. Has anybody done WebAssembly generally rather than Blazor? Not many people, actually. How are you finding it? So we did a Blazor app. I kind of balked my WebAssembly Blazor on the Pi, but you got the idea. There's a whole heap of links. You can find out more about Blazor on that first one. Don't worry about copying all these down again. They'll be in the slides. And then .NET Core 3.1, they do everything through these announcing .NET Cores. And then, if you wanted to cry yourself to sleep about the problems that you're having with EF Core, then you can go and have a look at that if you like. And then Visual Studio 2019, there's no reason why you shouldn't be using that now. And then here's the link to my blog on how to get that installed on your Raspberry Pi. And then the GPIO NuGet package, and then Blazor again. It's that important. Oh, I'm sure I've got two of those. And then if you want to contact me, you can hit me up at any one of those places there. So Twitter is generally the best place to send me a DM Connect and send me a DM, but you can send me an email just as well. And they're not online yet, but that's where the slides will be when they come online. See people take a photo, so I won't be rude and move on. Got it? That's cool. And then, so that was a little intro to .NET Core on a Raspberry Pi as well. And